Good morning, everyone. This is Dr. R. Anirudh Reddy, Assistant Professor in the Department of ECE, B. Raju Institute of Technology, Narsapur. And I'm here to deliver the content on the course name Microprocessor and Microcontrollers on the topic Register Organization of 8086. So, coming across the register organization of 8086, first of all, what is a register? So mainly register is nothing but it is used to store the data. So if you come across any type of microprocessor or a microcontroller, so registers play a crucial role in processing the data as well as giving the data out to the peripherals. So we'll have different type of register organization for each set of processors and the microcontrollers. So that will be unique to the concerned processor or to the controller. So if you come across a topic register organization of 8086, mainly this we have general data registers, segment registers, and pointers, and fourth, index registers. And fifth, we have flag register. So if you come across the register organization of 8086 microprocessor, so we have general data registers, segment registers, pointers, and index registers, and flag registers. So first of all, we'll go with the general data registers. So if you come across general data registers, mainly we are going to have 4 registers, that is AX, BX, CX, DX. So these are the general data registers. We have AX, BX, CX, and DX. So all these registers are of 16-bit. So if you come across AX, suppose if you come across any type of operation, so it can be done either in 8-bit or in 16-bit. Suppose if you want to perform any operation in 8-bit, then I can use either AH or AL. Suppose if I want to perform any operation on 16-bit, then I may use AX. So so based upon the type of operation we perform, so either in the 8-bit or 16-bit, we utilize the registers. So and if you come across AH and AL, there is no rule that compulsory we need to go with AL or we need to go with AH. So that's up to us which type of register we use. But preferably if we use AL register, it would be better. And coming to BX register, here also, suppose if it is for the 16-bit operation, we go with BX, and suppose if it is for the 8-bit operation, we go with BH or BL. And coming to CX, it is an mainly we go with for 16-bit we go with CX, and for 8-bit we can go with CH or CL. The same way it is for the data register. And coming to the usage, mainly the AX register, it is used to store the data. It is used to store the data, as well as it is used to store the results, as well as some immediate or intermediate values. So mainly these type of registers are used to store the data, results, and in some intermediate variables. Mainly this AX is nothing but it is an accumulator register. AX is an accumulator register, and BX is the base register, CX is the counter register, and DX is the data register. So if you come across accumulator, mainly for any type of operation we perform in 8086, we store the results in the accumulator register. So that's why in programming 8086, accumulator plays a crucial role. And coming to BX register, it is a base register. Mainly this is used to store the offset address. So offset address is nothing but some required address. So and coming to CX, mainly this is used as a counter register. Counter, suppose if you have some applications where we need to perform some counting data or any characters, then we go with this counter register. For example, if you take some operation on the strings or any string manipulation operation, example if you take a BVRAT, now you need to perform some operation or I need to read the data. So if you come across string manipulation instructions, so that can be done by character. So first of all, in order to read that concerned total characters, first of all we need to know the how much count the concerned character total string is. So that type of application, the count will be stored in the counter register. And if you come across data register, so this is also one type of storage register. Mainly this is used in case of multiply and divide instructions. Mainly this is used in case of multiply and divide instructions. So this is about general data registers. And coming to the segment registers, if you come across segment registers, we have code segment register, data segment register, we have stack segment register, and we have extra segment register. So out of total 1 MB of physical memory available in 8086, we are divided that into 16 logic segments. 16 logic segments where each size is of 64 KB. So these 16 logic segments will be divided by these 4 segments. Either it can be code segment, data segment, extra segment, and stack segment. So the use of these registers, it is used to point out the memory location where the code has been resided. So that is the use of the code segment register. In the same way, if you come across the data segment register, mainly this is used to point out a memory location where the data has been resided. And if you come across stack segment, this is also mainly it is used to point out the address or a memory location where the concerned stack data has been stored. And if you come across extra segment, so this is also one type of a data segment. Mainly it is used to point out a memory location where the data has been resided. So if you come across any type of assembly level programming in 8086, first of all, we need to divide, we need to segregate whether it belongs to which segments. Suppose if you want to write a program for the addition, if I want to write a program for the addition of two 16-bit or 8-bit numbers, first of all I need to initialize the operands what I have. So that will be initialized in the data segment, and whatever the logic we write, so that will be initialized in the code segment. Suppose if you want to perform any type of operation where we need to store the data temporarily, in case of that scenario we go with the stack segments. So especially if you come across stack segment, we use two type of operations. One is push and other is pop. Pushing is nothing but giving data onto the stack, and pop is nothing but retrieving the data from the stack. And if you come across extra segment, as I told earlier, mainly this is also one type of a data segment, mainly to point out the data on the data side. Okay, so this is about the segment registers. So next we come across pointers. Pointers, we have stack pointer, we have instruction pointer, and we have base pointer. So stack pointer is nothing but, as I told earlier, stack, it is used to store the data temporarily. So for example, some programming execution is going on. Okay, this is a main program. In between an interrupt got generated, then I need to go from the main program to the sub program. Then while I am going from the main program to the sub program, so obviously I need to store the concerned address or the data in some stack to store the data temporarily. So nothing but mainly we use a stack to store the data temporarily. So once if you are pushing some data onto the stack, someone need to be there to point out the data on the stack. So that is the stack pointer. Mainly we use the stack pointer in order to point out the data on the stack. So this will be incremented or decremented based upon the push or pop operation done. Now if you come across the instruction pointer is mainly it is used to store the address of the next instruction to be executed. And base pointer is nothing but mainly this indicates the starting address of the any segment. So as I earlier spoke about the segment registers and the segments available, so in order to perform any type of operation, we use the base pointer in order to have the segment address. So this is about the pointers. And next we have index registers. Index registers. So if you come across index registers, we have source index register and we have destination index registers. So we have two type of index registers. One is source index and other is destination index register. So both these index registers are used to point out some memory location. But suppose when we are going to use this type of index registers, Suppose mainly, first of all, we'll see what is this index register. So index register is nothing but it is used to point out or store the memory location of the source data, and destination index register, it is used to store the address of the destination data. Suppose think that I have a string called bvarit which need to be moved from the code segment to the extra segment, nothing but moving from data from code segment to the extra segment. Now these will act as source and these will act as the destination. Now if I want to perform this operation, first of all I need to know the source address and as well as the destination address. So that source address will be stored in the source index register and destination address will be stored in the destination index registers. Here we use this index registers. So and other one is we have flag register. Flag register is nothing but mainly it tells the type of status of the operation performed in the ALU. So suppose right now if you are performing any addition operation, so based upon the operation performed in there, so we'll come to know whether the carry flag has been set or not, whether the zero flag has been set or not, when the sign flag has been set or not, when the parity flag is set or not. So based upon the operation performed in the ALU, we'll come to know that whether the concerned status bits are high or low. So that totally we are going to know in the flag register. So that's all about the presentation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.